Uh, okay. Adarsha? Adikeshu? Can you hear me?
Sir. We can hear, sir.
Okay. Yeah. Okay. So in the last class, we discussed about the different quartz group of minerals and their uses and how it occurs in the field, and it's associated with the different rocks. Uh, you know, so let me show you those. Okay. Right. Yeah. So can you see the screen now, Adarsh? Adarsh or Adikesha, anybody can confirm? Screen is
Sir, we can see,
visible?
sir.
Right. So in
Sir.
the last class, we discussed about quartz group of minerals, quartz group and the two group of minerals. So we have seen the varieties of quartz, and generally we use this quartz for the manufacturing of glasses, and also the how it looks in the field. I mean, in the it's associated with the different rocks. Okay, so iron ore associated with quartz, and this is the pyrite pits, and this is a quartz vein where the gold occurs. Generally, it happens this type of quartz veins. It's that we call it as vein type of quartz, VEIN, vein type of quartz deposit. So it is that, and we have seen that, right? Okay, and feldspar group also we discussed in the yesterday. That's the feldspar minerals. Yeah, these are the feldspar group of minerals we discussed there, and this mainly used in the ceramic products and in tiles industries as a raw material for this. Okay, and also uh, we discuss the mica group of minerals, and that's called a biotite mica and muscovite mica, and these two we were used for the in electrical industries due to high heat resistance, the properties which is having this, and it's having the rich of the magnesium, iron, alumina, and potassium in biotite mica, and even in muscovite mica you can see the it's called silicate of alumina and potassiums. Okay, these are the mica group of minerals, and okay, these are feldspar group of minerals. So that I can just let me put you there in here. Okay, that would be the difference. So these are feldspar group of minerals. So this is how the things are here, and now uh, so let's go with the uh, okay, iron group of minerals, oxide groups, iron ore minerals. So what are those iron ore minerals? Okay, it's a ore minerals. What are those iron ore minerals? Here, these are the first column. You need to write down the properties. The properties are same for all the minerals. This is common. And next column, if the hematite, magnetite, bauxite, and corundum. There are four oxide group of minerals we mentioned here. There are many minerals, but for your the syllabus point of view, hematite, magnetite, bauxite, and corundum. There are goethite, limonite. There are many minerals are there. Okay, so this is enough for you. And magnetite and hematite and even bauxite. These are the most three minerals which are you know you know very important for the industry point of view, economic point of view. So because we use magnetite, hematite for extraction of the steel, iron and steel. Okay, and bauxite for alumina. Okay, and corundum generally we use for the gemstones. Okay, and how it looks. What are the main properties, physical properties of the hematite now. So let me show you the, what you call this, the photo of the field photos, and as well as, yeah, here you can see this. Hematite, and it's a magnetite. Okay, this is a knife, and these two are hematite, and this is a magnetite. Okay, so here this is completely grayish black, or reddish brown color. Okay, let me put this into the the slide. It would be a better for you so that you can easily, yeah, here you can see this. And here is the first property of this is a color. How it looks like this. It's a what do you call this, reddish brown, or maybe the black color here. Okay, generally it is a black color. Here you can see the properties. Yeah, yeah. So hematite, it's a massive. It's just a, the shape, the shape form is a massive. It looks like a massive one, and it's red or brown color hematite. This is reddish brown color, reddish brown color. You can write it is down, and this is a black color. Here you can see the black color. Magnetite is a black, hematite is the reddish brown color. And hematite and magnetite, these two are, the properties are very similar. Okay, there is no much, but when you take streak, when you rub with the streak plate is nothing but it is ceramic plate. It's made with a ceramic plate. When you rub with the streak plate and releases the color, that color we call it as an streak color. Okay, streak color. Let me show you the streak plate. It will be somewhere here in this. No, it is not here. Oh, okay. Again, let me have the streak plate here. No, we don't have the streak plate here. Okay, so yeah, this is when you rub with the streak plate, and it releases the color from the mineral called cherry red color with the hematite. Okay, and when you rub with the streak plate, the magnetite mineral, it releases the black color. That is a major difference between magnetite and hematite, and also the chemical composition. And rest of the properties are similar. Okay, and here, what you call this, a luster. It looks like a metallic luster. See here. See, when you see the iron, the final product of iron and steel gray color, it also looks like that. That we call it as a metallic clusters. Okay, and here is the hardness is 5.5 to 6.5, or you can write it is as a medium one. Okay, so the specific gravity is always high because of this rich of iron and silica. Rich of iron, that's why its specific gravity is too heavy, too high. You can write it down as a high. Okay, and this chemical composition. So hematite, Fe2O3, and magnetite is Fe3O4. Both are iron oxides. Iron, and here is oxide. That's why we call it as in, it's called a oxide group of minerals. Oxide group of minerals. Okay, and occurs where it is occurring. It occurs in sedimentary and metamorphic rocks, and this also in the same. Okay, and where it is occurring, and which part of India? You can say in Karnataka, Goa, Maharashtra, and even Madhya Pradesh, Bihar, Orissa, Chhattisgarh. Okay,
Sir,
northern part. Yes,
so the PPT is not visible.
is it not visible?
Now,
Visible, sir.
Huh?
now,
Visible, sir.
Visible or not?
Yes, sir.
Visible? Okay. So So this is, what you call this, yeah, I can zoom it out this better. Okay, so it occurs in sedimentary rocks, metamorphic rocks, and the places in Karnataka. You can see the Ballari, Sandur Spate. There are rich of iron ore deposits, and even mining also done there. And even in Goa sector, it will the complete Goa is covered with the iron and with the low grade of iron ore that's called a lateritized iron ore. And even if you go with the Maharashtra also, some part of Maharashtra there is iron ore and also this is bauxite. Okay, and in central northern part of India, in Bihar, Orissa, Chhattisgarh, okay, in even in Jamshedpur, Tata Steels, Tata Mines, Tata Automobiles, everything is there. There you can see the iron ore deposits, and we have enough to reach the iron ore deposits in India. Okay, and of course, we need to utilize, and we should use the we should produce the iron ore from mines for domestic purpose only. Then only it will be highly beneficial for all of us. Okay, if you export it, and it's a difficult to again import the steel with the double price, whatever the things. So if you produce a domestic and can produce the iron ore from our mines, and we can supply for the produce the what you call the steel plants, so it's best. That's the one. And uses hematite generally contains 70% of iron ore, and it's used as a ore of an iron ore and producers of steel. Okay, and same the properties are same for hematite and magnetite. Okay, and except that streak, when it releases the color, when you rub with the streak fluid, this mineral, it releases the color. The color in magnetite black, and even hematite, that's a cherry red color, and chemical composition is changed, and rest of the properties are almost same here. Okay, okay, let me show you some of the the field photographs, how it looks. This is as I would say, this is called our yeah, no, okay, how the Ballari sector. I'm not going for Ballari sector. Let me show you the field photographs. How the iron ore you can see the iron ore from there. Yeah, this is how it looks in the field iron ore. There is a lot of difference in the in your lab specimen as well as in the field. Here you can see this. This is how it looks, the steel gray color iron ore in the field itself. Here you can see this, right? Yeah, this is not an iron ore, it's a metal salt. Yeah, this is a iron ore. Okay, those who are near to the Ballari, Sandur, even in Chitradurga, and even in next to the Tumkur, that's called Chiknagnalli, there is iron ore, and even in Kudremukh, we have done iron ore mining there, and we produce a lot of iron ore from there, and we are supplying there to the called steel plant in Bhadravati. That's called Viswesvaraya Iron and Steel Plant there. So here you can see this abundant mines. Okay, this is how it looks in the field itself. Okay, yeah, here you can see this. You cannot identify. Yes, it's iron ore, because here you can see this. These specimens are so typical. The banding natures, you can see this iron and the that's called a silica rich of jasper, or uh, silica rich of material here. It's called banding nature. That's why we call it as in banded iron formations, BIF, banded iron formations. Okay, and here you can see this. This is how it looks in the field, and this is how it looks in our laboratory specimens. Okay, right. Now this is Calcite. Yeah, here you can see this. This is how the mines were happening there, and I would say it's yeah. You might have seen this type of exposures in the when you go for any trip, or it may be in the outskirts. Maybe you may not be identify, yes, it's iron ore, or it's maybe the bauxite, or it may be the quartz veins. Here you can see this. It's a complete of iron ore. Yes. Okay. Let me go back to the it's called iron ore mines, and so that this is how the it looks like the mines areas. Here you can see this iron ore mines. It's so difficult to distinguish. Yeah, this is reddish color. This is of rich of iron ore mines here. Okay, and a little bit top color is called that's top soil, that's called laterized iron ore, low grade of iron ores. And here you can see this. This is how it looks, the mines area. Okay. Yes. The typical of iron ore mines. Oh, this is so stupid. Yeah, I can see this. A typical of iron ore mines. Okay. But it's very, major difference in the what you call in our specimens and in the. But of course, you can easily identify those specimens. You can easily match with this what you call in other photographs. That's what we have shown you here. Yeah, here you can see this. This by looking this, you can easily identify the what is the iron ore, magnetite and hematite, that you need to check with your magnet. Okay, magnetite is generally attracts with a magnet, and the hematite is not attracting. That is another typical character of magnetite. Okay, yes, this is how it looks, the iron ore in the field, especially the magnetite and hematite. Here you can see this, the complete. Okay, this is just in the top of the hill, and when you go back and when you go with the deeper level of mines, so the top hill looks after maybe 10 years. Before that, it was in the top of this, maybe RL 900 something. Here it's 800. That means 100 meter. They have what you call it, mine it. That means each bench is 8 to 10 meters height generally. Height in the sense, this is a benches. We call it as a benches. From here to here, it's a 8 to 10 meters. That is, it depends on the strata hardness. If there is clay material, the bench height will be the 6 meters. If there is any what you call hardness, very hard strata, okay, hard rock is there, then we'll go for the 10-meter height. That is due to we fix because what you call the bench collapsion will happen because of the truck movement on this. So this is a one. This is how the iron ore mining is happening in India and all over the world. Okay, it is, we call it as a bulk commodities, and the one iron ore, the price for this, for 1 ton of iron ore price, it was in 3,000 to 4,000 in earlier days. It's for domestic, huh? For export, it may be a 78,000. Okay, it was in 2010, 9 to 10, that period. But now it is everything is come down, and the lot of mining activities has been reduced due to a lot of what you call this environmental issues. Okay, right. So these are all iron ore, these ones. Okay, let's go back to the let's call our the bauxite mines. How it looks at the bauxites. It is an oolitic structures. It's a brown color, and when you rub with the streak plate, it releases the same of brown color only. It's not a vitreous cluster or metallic cluster, and here is the yeah, yes. Uh, it's an earthy luster. It's not like a muddy natures. Okay, hardness is low to medium hardness. You can write it is, and medium gravity, and chemical composition is alumina rich. Okay, and occurrence, it occurs in an alteration of product of alumina rich rocks. Especially it occurs in Gujarat, Maharashtra, and even in Karnataka. Karnataka, where it is, that is especially in the coastal areas. Okay, that is a one. And here, from this, where we are, uses the principles, alumina or the manufacture of chemicals. Okay, and in the refining of petroleum products. Okay, this is a bauxite generally we use. Gujarat is a major, producing the lot of, the bauxite mines, even in Maharashtra also, coastal, especially coastal. Goa, Maharashtra, and even in Gujarat, this coastal west coast of belt can use this mining areas. And when it comes to the corundum, it's called its a form is a granular form, and its streak is colorless. That means that's a white color. It may be produced, and vitreous clusters. I'll show you the mineral specimen now here, and let us have the properties. Vitreous cluster, specific gravity, hardness is very high, corundum. And next one is the diamond. Diamond is the hardest mineral in the world, and talc is the tough, softest minerals. So corundum is the 9, hardness is the 9, and specific gravity is very high for this. Chemical composition is aluminum oxides. Okay, it occurs in metamorphic rocks. This corundum mineral occurs in the metamorphic rock, metamorphism of shales and limestones. Okay, generally we use this corundum for the as in gemstone qualities, and also for some of the manufacturing of abrasive materials. Okay, so let's have the bauxite and corundum. Bauxite and sorry, bauxite and the corundum. Just right here, corundum. Yeah, iron, calcite, copper. Let us have the corundum substance. To show you the the corundum, that is a very typical one. Laterite, that is in the coastal. It's in the bauxite. That's called bauxite. Sandstone, diorite. Okay, pegmatite shale. Yeah, basalt. Yeah, you can see this. It's nothing but the basalt. Sorry, the bauxite. You can see this rich of iron and alumina here. Rich of iron and alumina. It is generally occurs in the coastal of west coast of areas, Karnataka, Goa, and even Maharashtra, and even in Kerala also. Generally, we use this as building stones. That's the lateritic bricks. Okay, and to show you the marble, no, phyllite, slate. So bauxite, corundum we don't have. It's a very small. This one. I don't have here. Okay. I don't have a photos of specimen of corundum here. Let me show you in the next class that. Yes, this is actually, I would say it's a diamond. This is a one diamond. It's the toughest mineral in the world, and also it is a actually this diamond recently, I mean, in the 2 years back, got in the it's called in what's that? Madhya Pradesh, Panna district. Panna district, there is continuous artisanal mining is going on there, and where they you got a very good of what you call this diamond. It's a very typical one, and here it is. This it's not that much of clear the picture. Yeah. Okay, and it may be the cost of this diamond. It may be the more than crore rupees. Okay, so one of the farmer got this the diamond in Madhya Pradesh. Okay. Yeah, here you can see this bauxite. Yes, this is a bauxite. Let me show you some of the corundum here. No, we don't have corundum here. That is a typical one actually. This looks like a gemstones. Apatite, yeah. Corundum on a rock here. This is a corundum. The green, the gray color. Here, look at this. This is a corundum. Okay, and here it's in the rock. Wait, smoky quartz, sapphirite. Yes, only specimen, one specimen we have. Chlorite, marble, malachite. Okay. Let's see classifications. Yeah, that is the one. We have the corundum specimen here. Okay, that's we use as gemstones for this. Right. So let's move to the next one. That's called carbonate group of minerals. It's a carbonate group in the sense it's a calcite rich of minerals. What do you mean by calcite rich of minerals? Say, for example, if you take the calcite, and you can take the dolomite, calcite, dolomite, and magnesite. These are the calcite group of, sorry, the carbonate group of minerals. And these minerals are generally we use it for manufacturing of cement. Okay, and here these are the properties which we need to study for identification of the particular mineral. Say the form, color, streak, luster, hardness, especially gravity.
So,
Yes,
so your voice is not audible clearly.
is a yeah. Okay, I increase it. Right. Okay, so here, what we call this calcite, dolomite, and the magnesite. Okay, and the properties are same here. This is the first column is the same, and second is the crystalline properties. Form is the crystalline. How it forms? Some are massive, some are the radiating, some are crystallines. Okay, this calcite is like again crystals, and color is a pink color, pink, white, black, and blue. It may be a varieties of calcite. You can see that. Okay, and the streak is colorless. That we show that, and the luster is vitreous because shining of the mineral is very very vitreous, and hardness is a medium. Specific gravity is also medium. Okay, and the special character, the special property of the calcite is that it's a diluted HCl test. It reacts with this. Okay, and the chemical composition is CaCO3, calcium carbonate. Okay, and occurrence. Okay, it occurs in generally in Gujarat, even in Andhra Pradesh, Rajasthan. Okay, they will be right. And uses. What is the use of this calcite? I told you that the use of this calcite in the manufacturing of cement, and even in bleaching powder, textile industries, rubber, paint industries, and glass and ceramic industries. Glass and ceramic industries, we use this calcite because of this calcium in the manufacturing of the cement industries. And you might have seen the some of the what you call the limestone mines. If you are traveled in northern Karnataka, what you call in Bidar, even in Gulbarga, there is a called Wadi district, and there is rich of limestone deposit. So where there is the world best, the cement manufacturing companies are producing the cement that's called the ACC, Ultratech, Ramco. Ramco, it is in nearby called in Hasturga, that's called in Mathod plant. And from Chiknakanalli to Hasturga Road, there is Ramco cement. They are producing the what you call this cement, right? That's a limestone deposit is there. Let me show you some of the video photos of that so that you can easily understand how it looks in the field, the limestone and the calcite is there. And the dolomite. Okay, the dolomite generally it's associated with the limestones. Limestone and dolomites are together. Okay, limestones and dolomites are these are together. You can see this, and so there is a major problem in the limestone cement industries. If there is any rich of dolomite is there in the limestone, so it gives a lot of problem in the processing. Okay, of course, this dolomite and the limestones are occurs together in the field itself. Okay, that's the one thing. And properties are it's a crystalline same, and it's a gray color, and streak is also very, it's a colorless. Luster is vitreous. It's a shining on the surface of the mineral, and hardness and specific gravities both are medium. And of course, it does not react with diluted HCl because it's rich of magnesium, not rich of calcium. Okay, and the occurrence is widely distributed all over the India. This is dolomite, and it's used in the manufacturing of cement, lime, and fertilizers. Okay, and it's a pure dolomite is a good source of magnesium and used for refractories, and also used in used as a flux in metallurgical operations and even in glass industries. Okay, these are the major the very good what you call the economic importance is there for dolomite. Okay, and the magnesite. The magnesite is a massive nature. You can see the massive. There is no proper shape for this. It is not a foliated. It is not a table-like. It's not a sheet-like structures, or it is not like a crystalline. It's a massive one. Okay, and the color will be the white. Okay, so the streak is also white there, and dull lusters, and specific gravity and hardness will be the medium, and it's not react with HCl. Okay, and the chemical composition is MgCO3. Okay, magnesium carbonate, and the occurrence it occurs in the igneous rocks, in ultra basic igneous rocks, Just you can remember that it's in occurs in igneous rocks. Okay, and uses where we are using this, magnetite. Magnetite generally we use it for manufacturing of refractory bricks, for furnace lining, and even in electrical elements. Okay, generally in the for furnace lining in the sense, and even in refractory bricks, where there is a called cement manufacturing and the steel manufacturing industries. There is steel manufacturing industries, we call it as a blast furnace, and cement manufacturing industries, the processing unit, one unit called a kiln. Okay, there inside the kiln, they are coating with refractory bricks lining, furnace lining inside that's refractory bricks. That will what you called it reduces the heat, because it's the kiln, the temperature is more than 1000 degree during the processing of the cement. Okay, let me show you the some of the photos of this, so that you can easily understand how this refractory bricks, what we are shown here. So dolomite and magnesite, right? Dolomite. Where is the dolomite? So minerals. Okay. Magnesite. Yeah. Yes. Here you can see this. This is magnesite, calcite, and dolomite. Dolomite is the gray color actually. As I told you that this will be the gray color. Okay, and okay, let me put it in the next to that, so that it will be easy for you, right? Yeah. Yes. Yeah. Come on. Okay. The picture effect, the shadow, right? So here you can see this. This is a magnesite. It's a white color. Okay. It's massive one. There is no shape for this. But when you see this, the calcite, it may be a varieties of color. Whatever you can see, this is a pink, but it may be white, it may be a black, and even it's different colors. Okay, and streak is so colorless. It's a white, and it reacts with HCl. That is the one thing. Okay, and here is the dolomite. Dolomite is a very well crystalline. Okay, it's a gray color. It's a dull color or gray color. Okay, and it's a little bit shining. You can see this vitreous luster. Vitreous luster is nothing but, yeah, the mineral surface of the mineral is shining. These two are, but here this is a very dull luster. It's not shining on the surface of the mineral. Okay, and specific gravity and hardness is medium for all the minerals, all these minerals. Okay, and what are the typical character here? Yeah, it's rich of calcium carbonate. These two are, and magnesite is rich of magnesite, and dolomite are rich of magnesiums. Okay, and generally we use this for manufacturing of cement industries. Some manufacturing of cement. Okay, limestone is the source of raw material for manufacturing of cement, and in that there will be a calcium as well as the dolomite along with that. Okay, right. uh, we can see this sort of we use what I've shown this we call this limestone, that you can limestone mines, that you can easily understand this what's going on here. But it's very difficult to get the the clear picture how it looks. This the I want the bench wise. Yeah. No, it's not properly. Okay. Okay. Yes. Here you can see the limestone mines, and these are the benches. Top is the, the top soil. It's nothing. It's a waste for us. We call it as a overburden waste, and down below that's highly weathered zone, and down below this is called your pure of limestone here. Okay, and generally we used to drill it and put the what you call the blasting materials, and we'll blast it and transport it to the what you call crushing plant. There will be primary crusher, secondary crusher, tertiary crusher. Then it goes to the grinding mill, and from there grinding mill it goes to the kiln. That's we call it as a kiln, where they are processing the liquefied this the raw material into the liquefied through the passing through the high heat steam called kiln, and they are producing the cement from there and adding with the gypsum. Okay, finally it's adding with the gypsum because it's having the bonding natures. Okay, so this is how it looks, the uh, limestone mines. Okay, and you have seen the iron ore mines. This is how it looks, the iron ore mines. It's a black reddish color, and when it comes to the limestone mines, it's completely white. Okay, it's a rich of calcium there. Okay, here is the rich of iron and steel, sorry, iron. Okay, right, and here you can see this. Okay, these are all the the iron ore group of minerals and carbonate group of minerals. Carbonate group of minerals: calcite, dolomite, and magnesite. And iron ore group of minerals: hematite, magnetite, bauxite, and corundum. Okay, and these two are very important group of minerals or industrial oriented, and we need this raw material for manufacturing of iron and steel and cement. Okay, right. Okay. Uh, yeah. Let me ask you the some the key questions. Right. Okay. Okay. Right. There is a quick quiz session now. What is the physical properties, and what is the chemical composition of hematite? Anybody can answer this. Chemical composition of hematite. Adarsh, Adikeshu.
Yes, sir.
Chemical composition of the hematite.
Sir, iron and wait.
Yeah, iron oxide is correct. But iron oxide, exactly, I would say it's a Fe2O3. Okay, it's iron. It's iron. What's the use of this hematite? Chiranjeevi, what is the uses of iron ore?
Sir,
Uses of hematite,
hematite, it's used in iron and steel industries.
manufacturing of iron and steel industries. Right. What about the corundum, Darshini? Corundum minerals. Where we are using these corundum minerals? Deepthi?
Gemstones and
Yeah,
abrasive materials.
abrasive materials. Correct, correct. And what about this calcite? Chemical composition of calcite. Dhananjay Kumar Singh. Chemical composition of calcite. Divyasri. Divyasri. Okay. Harini.
CaCO3, sir.
Yeah, CO2. What is the use of this calcite? Where we are using this? Harshavardhan, Harshita.
So construction materials.
Calcite.
Cement industry. Cement manufacturing.
Yeah, manufacturing of cement.
Mainly used in lime.
Yeah, yeah. It's a rich of calcium, and we use for the manufacturing of cement industries. Right. Right then. Okay. You got how to identify the physical properties of minerals, but some extent I would say it's very difficult. If you have the specimen in front of you, if you feel that if you hold it and you can get the experience, that's a very good part. But as of now, you can see in the slides. So when you come to the college, you can have a look the all the minerals and rocks. Okay. Do you have any doubts on this, on these properties, and how to remember? And you need to understand where it is occurring, how it is occurring, how to identify this. First of all, you must understand what are the properties, physical properties of minerals. Okay. There are 8 to 10 properties are there. Okay, that you need to understand first. Then you can easily understand the things. That's why I'm showing the the field photographs as well as the mines, and also the laboratory in the lab specimens. There is a lot of difference in the lab specimen and even in the what you call in the field photographs. You have seen that. Okay. And you can easily identify those things. That's not a big issue. Yes, sorry. Right.